histograms. So we need quantitative continuous data that's in a grouped frequency table. We need to check if the data has been rounded. We work out the class boundaries, class widths, and we can use this useful relationship between frequency density, frequency and class width. Example 1. Working out the lower class boundary and upper class boundary. So we have data here which is not rounded, and the class interval here 16 to 20, and where this ends this class starts 20 to 30. So these numbers are the actual class boundaries. Now we've got heights which have been rounded to the nearest centimeter, and we can see there's a gap between the upper boundary here and the lower boundary. That's because these numbers are not the actual class boundaries. So we need to go half a unit above on this one, so 19.5, and half a unit down on this, so 19.5. So these are the actual class boundaries. So 15.5 to 19.5, and then 19.5 to 29.5, and we use these values to calculate class width. When it comes to age, we don't round, so the boundaries here are 16 all the way up to but not including the 20th birthday, and here starting from somebody's 20th birthday all the way up to but not including their 30th birthday, like this. So we have boundaries which are like this. An age of 16.7 years is still 16. It's not rounded up to 17. Example 2. So we have a grouped frequency table, and we're given some information about this particular class, and we have to work out the width of this class. The data has been rounded, it tells us here, to the nearest whole number, hence the gaps 10 to 15, and this one doesn't start from 15, it starts from 16. So we have to be careful with the class boundaries, which are these. This class interval has a class width of 6, and on a histogram the bar for this particular class is 2 centimeters wide. Now this class has half the class width, so on the graph of your histogram the width will be half of this as well, so 1 centimeter. Now we need to work out the height of the 16 to 18 class. For a histogram, the frequency is proportional to the area. So for the given class here, the frequency is 15, the area, so 2 times 5, is 10 square centimeters. The class we're working with has a frequency of 9, so the multiplier here is times 9 over 15, so the multiplier on this side for the area will be the same. So this value times 9 divided by 15 gives us 6 centimeters squared. We already know the width here is 1, so the missing value is 6.